Hello, everyone. As mentioned, my name is J.L. Gray, and I did recently join Cadence back in August. And I was asked in September, I was visiting some folks, and they said, "Hey, J.L., could you present something at this the TVS forum?" And, I said, "Well, what should I present about? I've just joined Cadence, so I don't know if I can talk really about all the Cadence strategies and products and things." And they said, "Well, come up with whatever you like." So I came up with whatever I liked, and what I like is to maybe prompt, whether we have the discussion today or whether you have it back at your office, a discussion of some thinking about the fundamentals of verification. You know, when we go off to verify a design, what are the basic things, the actual fundamental things that we need to care about, and what are the things that are just, maybe best practices that are applicable for a certain situation? I think it's easy to get confused by these, and so let's explore. And if you agree or disagree and you feel very strongly about expressing your opinion during the presentation, you may, feel free. If not, no problem. But I've never shared this information with anyone without them having some dramatic reaction. So what I'm going to talk about first is we're going to talk about the mission. What is the mission? If we don't understand what the mission is of verification, we're going to have a really hard time understanding and deciding whether the solution we're trying to apply to a problem is really a fundamental thing, or it's the wrong solution for the problem. My theory is that there are some rules and behaviors that we all tend to follow in our teams. And again, if you think about it and look at the fundamental mission, I'm going to claim that some of these rules are really not rules at all. So we'll go through that as well, and then we'll just kind of summarize at the end. Mission of verification. Now, this is a good one. I expect if I asked all of you what's the purpose of the verification engineer, would this sound about right? Yeah? No? Is this the right conference? I don't understand. Maybe these guys aren't verification engineers. I apologize. So, find as many bugs as possible. That sounds great. And I heard someone else say the other day, well, actually, we'd also like to make sure, we find as many bugs. We want to find all the bugs. Every bug. We want to find every bug. Okay, well, maybe. But I'm going to claim that the actual goal is different, subtly different. We would like to find, or we would like to deliver a chip to our customers containing as few bugs as possible. Now, maybe that sounds like the same thing, but it's not. Finding as many bugs as possible is great, but I want the end product to have as few bugs as possible. So if there's a lot of bugs to start with, for example, and I find a lot of them, I still have a lot left. This is a problem. It only matters in the end what the customer sees. It doesn't matter all of our fancy test benches and coverage plans and the awesome formal theorem proving and everything, right? It's all fancy, but nobody cares. When you take out your iPhone, nobody cares who buys that phone. They don't even have any clue that any of us exist. It's a magic box, right? Okay, so this is, I claim, the real goal. Now, what does that mean? I've listed 5 rules and 5 behaviors I think that we tend to follow. Maybe some of you don't follow these, I don't know. But I think it's pretty representative based on my consulting experience that these are things that people tend to do. And we're going to go through each one. So let's talk about the rules. Rule says, I think you would agree, many of you would agree, it's very, very important to separate design and verification tasks. Why? Well, okay, I had somebody refer to this recently as the teamwork bug. I think it's kind of a nice way to say it. So you have a bunch of people working together, they're sitting around, maybe they're having a beer or a coffee, and they decide, yeah, this behavior of the device, it's probably okay. It's probably okay. So we'll just allow that we'll change our test bench, we'll let this behavior go through. Product goes out, and then of course this is a wrong bug because it was really, these guys working together, they kind of agreed in the wrong way. Okay. Another reason to separate the tasks is because you have designers, they have special skills. You have verification engineers, these have very special skills. I mean, it didn't used to be the case, but now, all this, how to write these fancy object-oriented test benches and all sorts of great things. So why not let the teams do what they do best, design verification? Sounds pretty reasonable, right? Or no? Maybe? And blank stares. So the last thing here is to say we'd like to kind of free the verification engineers to think of crazy things, right? We don't want them to be, again, the teamwork bug, we don't want them to be so much influenced by the design team. But I'm going to claim that while this sometimes might be a good idea, it sometimes is not. And that separating the design and verification teams may, in some cases, cause the quality to be worse. Why? Well, first of all, you have this design, and that's kind of a magic box to the verification engineer too, to be honest. The designer has put in all sorts of neat, special, fancy features, secret switches and FIFOs and fast clock domain crossings and everything. The verification engineer is going to have a hard time knowing about these things if they are separate. And not knowing about these things is, you have to know. If there's a clock domain crossing in there, you have to know about it. Maybe the spec is supposed to have it in there, but come on, right? I mean, come on. It's just not true. The specs are terrible mostly. Or you'll get an awesome spec with 1,000 individual bullet points numbered, which doesn't make any sense anyways. So you could have this spec. I saw one of these once and it had all these numbers, and I asked the team, do you know what it means? No, but they know what they can verify this feature. They have no idea what it means. Having the teams work together allows the more productivity, right? So you have the verification engineers, the design engineers, they can share information. It's just like, if you have a layout tool or the synthesis tool, the front-end tools, and I'm not an expert at this, so if this is total bull, then you can call me on it now. But effectively, as we get more complicated, it becomes necessary for these tools to share information with each other. So that you don't have to do all of the synthesis without understanding a little bit about the place and route and vice versa. So in the same way, we should, I think, focus on, it's a good idea in some cases, to make sure that the teams are working more closely together. Okay, that's one. Okay, one. Okay. So a boss comes to you and says, hey, Ken, here's a by the way, I love to see I have so many good friends here. It's nice to see all of you. So I can pick on you by name. It's the best part. So, hey Ken, I have this block and I'd like you to verify it. Here's the specification. Now Ken says, being a great verification engineer, the best, one of the best, top notch. So yes, I'll take it. I'm going to take that spec and I'm going to start verifying that. I'm going to dig into it. I'm going to write the best test bench. I'm going to do all these things. And in theory, right, you might expect that these blocks, and it's not a bad theory necessarily, that the blocks maybe should stand alone, right? You should, in theory, the block as specified, you should make sure that it works as specified, and you shouldn't need to care about the rest of the system. You shouldn't need to care if the designer has actually verified this thing, or that that if the spec is correct. You should know that just, okay, the spec is nice, I'm going to verify that. But in reality, as we just said, the specs are almost never golden. Okay, and the designer's goal is to make it work, but our goal is to make it break. So to make it break, we need to understand more. We need to understand how this block is going to be used in the system. Now, some people will argue, okay, but this block is an IP block. We have no idea what the use case could possibly be. I mean, really? You have no clue? I don't believe it. You must know a little bit. You know that somebody is going to, maybe they're going to use this, it's a DMA engine, they're going to use it in video. Okay, I worked on a great chip where there were all sorts of great features in a DMA for video. And I asked, wow, there's a lot of different ways to draw the menu here. Can you tell me about that, Mr. Designer? I said, yeah, well, I don't actually know how the software guys will use this. So I've included a lot of great features for them to use to draw the menu. But which one should I verify first? But all of them, we don't know. And as it turned out, none of them were the right ones at all. So in the end, they had to add some other feature because these features were nothing to do with the useful use model of this block. So designer gives us something, we think we should verify it. But maybe you should ask some more questions. Don't just verify what they've given you. Ask further, dig in, be a pain in the ass, sorry. don't give in. Make sure these guys earn their money. Okay. Okay. Here's another one. And I now work for an EDA company, so I guess I should say that you guys should all go out and buy some licenses for the best EDA tools, and you should use them fully. System Verilog or E and UVM. I mean, I was also on the UVM committee, so definitely it's the best. It's an industry best practice, right? So sometimes people will say, hey, look, we should be using in our company, we should be using these tools on everything. And if we're not using System Verilog, UVM, E, UVM, then something is wrong because you're not doing a good job. This is the state-of-the-art methodology. That's true. It is the state-of-the-art methodology. But do you understand correctly when to apply it? So it's not always the case that, that a test bench in E or System Verilog is the right approach. So, and I don't know if this is concern or if lunch is no good or, sorry. So, maybe it's a full chip. I mean, a lot of you guys do full chip test benches, I assume, yeah? It's not so easy to use the System Verilog at the full chip level. It may be too slow, right? It may be the case that the designer needs to do some verification. This is another topic. We'll get to that. Designers, they're a simple lot, right? They may not be able to fully handle this advanced test bench. It may not be the right choice given the resources that you have available in the situation at hand. So, it's a good idea sometimes, but you should be free to say sometimes it's not a good idea. This is really, if you come down to the point of this presentation, sometimes it's a good idea, but it's okay for it not to be a good idea sometimes too.
Can I ask a question?
Oh, yes, yeah. Of course.
I'm behind you.
Yes.
Because we don't see people using UVM a lot at system level. Typically, it's running C unembedded processes. Is that, would you say,
That's normal. Yeah. But what I'm saying is, it may be that there's pushing to start applying these methodologies into those areas.
And do you think they're applicable?
Not necessarily, no. That's what I'm saying. So I'm saying you guys may be doing the right thing, and you may see something shiny and say it's great, but it might not be great. It's okay to question it and say this is, yes, maybe I don't like it because it's new and I'm old-fashioned and I like old things, but maybe it's also not a good idea.
And just following on from that, do you find people doing more directed at system and less constrained random? Is that one of the issues as well? If you don't actually need it because you want to do directed?
Well, I don't know. I bet we have the experts here. Who's doing a lot of directed testing at full chip? Anyone? Directed test? Who's doing constrained random at full chip? So some the same and some different. So I guess for those people on the web, there was probably a few more hands for directed, and if there's anyone there. Yeah. So there you go. So don't ask me, these guys know more. Okay, here's another one. Functional coverage everywhere. Sweet, right? We have a great way to report data to management. Managers love data. They love charts. They have to be shiny and lots of colors, and they have to show 100% preferably. If they don't show 100%, then you should change the chart so that the percent. Because it must show 100%, right? This is otherwise the asset. And then give me a date when it will be 100%. I could be tomorrow if you give me 5 minutes, it will be 100%, no problem. Okay. It's great, actually. It is really good. You can track this information. You can track what you're doing. Okay, but you get to 95% functional coverage, and what happens? Man, all of a sudden, there's some crazy things in there. You have some cases that you'd like to cover, and it's very difficult. And then the manager says, well, why is it only 95%? Again, because if we added something in there, it's too hard. I could take it out, but it's kind of important. But it's not like you're stuck, right? We have other tools. So just because we have functional coverage and we're all, verification engineers, I guess, here, you don't have to just rely on these things. There's this thing called like actually looking at the code. You can pull it open. It's okay, by the way, to look at design code. Do you guys, I assume, who thinks it's okay for a verification engineer to look at design code? Who thinks it's not okay? Yeah. Just take this guy out. He doesn't know. No. Sorry. Okay. Now we know. We know what to deal with here. I get myself in a lot of trouble. Luckily, I have a flight very shortly after this, so I can just go. So, anyways, it can take a long time to finish these things. If you need to do it a different way, remember the point is not to have a fancy coverage plan. Nowhere in the point of being a verification engineer, in the secret oath we all took, you guys took the secret oath, right? In that oath, it doesn't ever say anything about this. Have to have 100% coverage of everything. There's nowhere in there does it say this. So if you need to do, reviews or waveform inspection, right? It's terrible. But maybe you have to do it sometimes. So understand that it might be okay. You'd like to avoid it. I'm just curious, the waveform inspection. Who would agree this could be a possible way to collect their final functional coverage? 1, 2. Who would say this is a terrible idea? Yeah? Great. I mean, it's a good question, right? When is it okay to do this? My reaction in the past might have been never. Never, ever should you ever do this. This is ridiculous. This is like caveman stuff. But, you go around a lot, you tend to see a lot of cavemen, and you think, well, maybe it's okay. There's too many of them. I don't want my life to be in danger. I should at least accept that it's possible, right? It's possible. Okay. Now here's one. This is really simple. It's kind of not in the same scope as the rest, but separate driver and monitor. Who does this, separate driver and monitor? Basically, you don't have them rely on each other. Who doesn't like this? No one. Everybody here, really? I don't believe you. There's some old-timers here who aren't speaking up, because I know they've done this. I know they've written the driver and the monitor together. They've written them all as a big squishy block. I know they have. They don't want to reveal themselves. Okay? It's stupid to have your driver rely on your monitor, or to have your monitor and your driver squished together. It's stupid, right? Why would you do this? Because then, if your driver's not there, you have no idea what's going on in the system. Yeah? And if you have your monitor as separate, you can do vertical reuse. You can use this monitor in the full chip. Except a lot of you are doing directed tests. Maybe it's not useful, I don't know. And you can collect coverage of what actually happened as opposed to what you think happened. I don't know, I also did sales at Verilog too, and some of my sales training, I don't know if this will translate correctly, but one of the instructors used to say that if people had these these unrealistic expectations, they were smoking hopium. Don't know, maybe some of you will get that. So they're having too much hope. They have too much hope, and they think, so if you're doing this, right, anyways, that didn't go over so well. So, why not? When is it ever okay? Is it ever not to do this? To have your driver be the source of your monitor data. You might have had some crazy designer, right? They may have created some insane interface. It's on the outside of the chip. It'll never be on the inside of the chip. Famous last words, but maybe it's too hard, takes too long. Again, this is a guideline, a best practice, but does it have to be a rule? Not always, so as I claim. So maybe it's okay sometimes. Maybe. Okay, so those are the things which, again, I'm claiming those are rules that I think we tend to follow, but which may have reasons why you don't want to follow them. Now let's talk about some behaviors. These are things I think that we do maybe without thinking about it. It's not that we really think about them as rules, but when we act on our verification tasks, we think, yeah, okay, this is, you just behave this way. Ah, okay. when you go to root cause an issue, how many of you have the verification engineers spend time trying to understand why tests fail? Anyone? Oh, come on. I've worked with some of you. I know these things. So why not? The verification engineers ran the regression. They see the fails. I mean, heck, it's probably the verification environment that's broken anyways, right? You might as well to have the verification engineers check to see what the problem is. And really what you want to come to, right, is you want to know, why did you miss this bug in your verification previously, right? So, you know, the question always comes back, hey, there's a bug. Why did you miss the bug? Well, it's good to know. But to be honest, why did I miss the bug is the wrong question. Better question is, why did the designer put the bug in there in the first place? Okay, that's a different question, and it's harder to understand. To understand that, you have to have different people in the room to root cause issues. You need to have a software guy. Do you guys know who your software team is? Mostly? Who knows, who works with their software team on a regular basis? Yeah. Who not? Who doesn't usually get to see the software? Yeah, I mean, that's pretty common, right? That you have no idea who the software team is. I worked with somebody once. The software team was this. I said, wow, do you ever work with the software team? They said, no. I said, well, where are they? Are they far away? They said, yeah, they're downstairs. So then we had a 2-hour meeting with them to discuss why we should work together. But, you know, it's a big deal. Root causing issues requires multiple disciplines. If you want to know that the reason why this bug is here is because the spec changed, and a designer A changed his code, and designer B forgot to change his code, and designer C went into designer B's code and made a change without anybody knowing, if you want to know that, you have to have all of those people together. You can't just see those things by just sitting with the verification team. So again, it can be really great. You know, verification team can summarize the issues, but if you really want to have, I think, the full picture, you need a different process. I claim. Ooh, nobody does this probably. Maybe this is a wrong slide for you guys. So the manager comes and says, hey, we've got a great news. We've just sold a $100 million deal to a top secret customer. The only catch is it has to be ready. See, it's November. It has to be ready by March. If it's by March, they will buy $100 million worth from us. If it's by April, nothing. So please design and verify this chip by March. Does that happen to any of you? It's like not March, February. He's like, February, actually. So why? Well, okay, there really is a business reason for this sometimes. You may literally lose the business if you can't finish in time. Also, it really is it's not so fun to have the manager pressuring you all the time. So if you tell them that you will be done in time, then and you align your schedule and put all the tasks correctly, you have at least a month or two before they notice that you were not correct. So that's good. You know, you can take your Christmas vacation. That's nice. Here's one that I think is really some people have this idea, and it may be true, right? We're going to be late. We're going to be late anyways, no matter what date we pick. So maybe the manager says, you know what? I'm going to pick an early date because I know they're going to be late, and if I pick a later date, they'll just be later. And everybody will be so motivated because they love working for our company, and they will work really hard, and they will be so happy when I tell them at the end that I was lying about the early date. Maybe. Okay. Maybe there's some managers here. Everybody's being quiet now. It might be okay to do this, actually, surprisingly. Might be okay. If you are willing to prioritize your design and really prioritize and say, look, we know we have 4 months. Let's be honest. Here's what we can do in 4 months. maybe it's okay. That would be okay. But if you don't do that, there's a possibility, right? So the possibility is that then the teams may not trust each other anymore. So the manager, even though they applied the pressure, they were actually thinking, geez, I don't know, they could have told me it would take longer, but they didn't. They just went along with what I said, even though I would have punished them had they told me the correct information. So there's no trust, and that's no good. But the worst part is, because remember, our goal is to deliver a quality product to the end customer. Test bench doesn't matter. So if we set up ourselves to be missing promises to our customers, this might not be a good thing. So it's tricky, actually. I think the business side of this can be very tricky, but I'm going to claim that it's not a great behavior. Oh, okay. Another one. So sometimes, do you guys work with really awesome designers? These guys are superstars, right? They're like, there's a Scottish thing that I think would be a good perfect to say, sunshine coming out of their, yes. They feel this way about themselves, right? I'm not so culturally sensitive sometimes. They've been on the standard committee for years, right? They know everything about, PCI Express or Slim Bus, or I don't know what to pick something. The DDR, they know all this stuff, and so if you come to them with the question, really you're supposed to come to them with a question, and you actually, they're really the expert. They actually, they're world-renowned expert. So you should trust them. If you have a question, they're the right person to ask for help. And kidding aside, they might be the right person. They may be the only person in the world who knows the answer. Probably not usually, but sometimes. So it's good to rely on them, right? But here's a problem. So I wrote up here, trust one, no one. I don't know if there's a show in the US called The X-Files where this was a theme of the show. Trust no one. Because it's, you just had the guys trying to solve a mystery and you can't trust anybody. As verification engineers, we probably can't trust anybody. So, including... Perfectly timed. We can't trust everyone. So just because somebody who they may actually be an expert at this thing, if the chip goes out with the bug, now it was their fault, but we're going to get blamed. So we should question. And again, now they may be the world expert, but to be honest, sometimes they're not, and they may just have made a guess just as good as your guess. It's good to push these guys sometimes. Let's see. Okay. Verification requires specialized skills. We were having a discussion about this at lunch, I think. Here's the gist. Everybody knows, right, that you need to have separate design and verification engineers, right? Because it's too hard to verify design without knowing all these OOP and constrained random and UVM. How could you do a verification job without this? Well, in designing, right, these guys have to know how to synthesize their code. They have to think about architectural issues in low power. There actually are some very fundamental differences in the kind of skills involved sometimes. But let me ask a question. How can you, back up. Design for verification. Good thing or bad thing? Good thing? In practice at your company? So the hands mostly go down, few. How can you design for verification if you don't know how to verify? So, sorry? You don't, right. So it's tricky, right? Because on the one hand, everybody has these really good skills in the areas they're experts. On the other hand, if the verification engineer doesn't know how to do design, it's hard to verify that it's working because you might not think of all the issues. Conversely, the designer doesn't understand. They're happy. They did this cool design. It's really fancy. They saved 5 transistors based on a really great architectural enhancement that they made that they'll surely get a patent from, which causes 3 extra months worth of verification. Yeah, that happens a lot actually, unfortunately. So we would like to, if you have experience, let the teams work together instead of separately. I think you may find that you can improve the quality of the design based on improving the quality of the designer's understanding of verification. And let me just, okay, good, we're almost done. So all things are created equal. Okay, what I mean by this is, do any of you work in maybe safety or military kind of applications? It's maybe a couple. The military guys are like sitting on their hands like can't say. So I gave a presentation once at an aerospace company, and I was talking about prioritization, and how important it was to prioritize your design requirements and verification requirements. And the manager of one of the senior guys stood up and said, well, I mean, all of the requirements are important. They're all important. The customer, like if it's a government, they may have this great list of requirements, and they literally have a law somewhere that says if it doesn't meet all these 1,000 requirements exactly, then we can't purchase it, or something. So they're all important. Or maybe this design is very carefully constructed, and the requirements are important because of safety. Maybe if one of these features is not there, something bad will happen. And so because of this, everything is really important. But I don't know about you guys, but when everything is important, I mean, nothing is important. It's all the same. So I may go and I'll pick one requirement first and I'll start to work on it. That's the prioritization that's happened right at that instant. But nobody, that requirement might only cause me to break my arm. And I skipped the requirement that would have blown me to pieces. So if you don't have a chance to prioritize, so again, sometimes we allow this thinking in our project teams that everything is important. An analog to this would be that we have to have 0 bugs. We don't have to have 0 bugs. We have to have 0 important bugs. Right? We won't, if there's some little weird thing that's wrong that nobody cares about, it's not important. But if it's going to blow me up, I care much more. So, what do we take away from this? Remember the mission. It's not to find as many bugs as possible, in my opinion. It's to make a product that has the fewest bugs. Understand all the rules. I mean, understand the best practices, but understand too that we may not want to follow them in some cases. Just because they're best practices, there's a difference between absolutes and best practices. If you understand the rules, you can break them. Right? That's what an artist does. They understand the rules and they know how to take liberties with the rules. And I'll just end with this quote, which I really like, which is, in theory, there is no difference between theory and practice, but in practice there is. And that's all I got. Thank you. Yeah.
So we're going to go to I've got a question first of all.
Yes.
Take the liberty of asking first. In terms of saying, in terms of bug, I think at the end you said that not everything's of equal importance. Isn't that the same with bugs as well? And shouldn't you be trying to find those bugs that, if they were in there, would stop the product, rather than ones that would just maybe make it slightly
Yes. So actually, I guess maybe I wasn't clear. To me, there's a set of features that are important. And to me, you would want to know which those are, and you would want those ones to be having the best quality first. I always like to think of it as if somebody came to me tomorrow and told me that I had to stop verifying this project, could I actually deliver something that was working? Like, that was working with the important features. So that would include, obviously, wanting there not to be these important bugs in there.
And I guess working with the software team helps there, because you can actually do a product verification rather than a hardware verification.
Yes. Yes.
Okay. Any questions from the audience? Okay, let me get over there as quickly as I can. That seems to be the most popular seat for questions. That one.
Hey, my name is Jürgen Schmidt, Synopsis. On the question, growing designs, it's more design complexity, doing more, doing better, quicker, that's a normal thing. It was so since 10 years, it will be this way next 10 years. What would you think is abnormal in the verification?
Abnormal
Yes,
today.
Abnormal challenge.
An abnormal challenge. So I didn't really touch on it in this presentation, but it was one of the challenges was mentioned that, actually I did touch on it. One of the challenges mentioned was that the design should have fewer bugs. I think that was from ARM, was it? You should remove the bugs.
Yeah, the designer shouldn't put them in the first place. There's a few people who think that.
Yes. So I think an unusual challenge might be, what if we've missed the point? What if we have too many verification engineers? What if the processes that this verification gap that we have, what if, looks like a bottle of water, what if that gap is actually caused by us? That would be a problem, right? What if the more verification engineers you add, the worse the quality gets? It's worth considering, because the designers then don't understand how to verify it because they don't have to, so they're not impacted by their decisions. That would be really a fundamental flaw. So that's something that I've been thinking about recently. Of course it is.
Just taking up that theme as well, we do a lot of software testing as well. The software community's moved to Agile, where there is no distinction between developer and tester. Do you think that's something we could adopt, Agile? I know there's a few companies who actually use Agile, but it's not very popular.
For hardware design.
Hardware design.
Yeah.
Quite popular in software, but not in hardware.
Well, let me ask the audience, I guess, how many of you have used Agile processes in your chip project? 1, 2, so not 3. Yeah, I have also done it, although it was kind of like Agile light. Like we just kind of tried to take, it doesn't make sense. You look at the book and it sounds really good, and then you try to do it and it doesn't make sense. It's at the first, so you have to work through you have to learn about it as you're going. So I think it's possible to do this for chip design. If the designers and verification engineers were more similar in their skill sets, you could do that cross-pollination of the work. Right?
Yeah. Or maybe pairwise development as well, which is another Agile technique.
Sorry?
Pairwise development.
Pair programming.
Pair programming,
yes,
yeah.
sure.
Yeah. Any more questions? Okay, thank you very much, Joe.
Thanks.
Thank you.